Thank you. Well, first of all, I want to echo Larry's comments. You know, here we are. When we set all this up, I don't know about you guys, but I've always looked at Memorial Day as like the last, right at the end of the month, you know. So the fact that to have such a nice group of people coming out on their, you know, on a holiday weekend is wonderful. And I want to thank you guys for taking time out of your day, or pretty much giving up your Saturday for this. And also I want to thank Larry and the Alabama Broadcasters Association for this opportunity to come down and talk about audio processing today. What I want to do actually is I know we want to focus in on the digital side, but I'm going to cover the whole gamut, and we'll start about with respect to talking about audio processing for in general. We'll talk about what we do with conventional radio. I'm going to focus primarily on FM, but I know that much of what we'll talk about today can be applied to AM as well. And when it comes to the HD radio side, we're dealing with coded audio, lower bit rate on AM. But again, much of what we'll talk about today can be applied to AM. And if somebody has a question that's AM related, you know, raise your hand, and if we need to get specific about something, we can. As you can, at times you'll probably hear me offer up analogies about cats that happen to be in the mafia or Sicilian, because that's my nature. And you know, some of you may know that I have this little hobby known as 8th scale live steam railroading. So getting started, I came into work one day and this sign was sitting up above my office, you know, steam powered man cave, and there's a lot of truth to that. So actually, good, you guys got it. Now, I have to tell you where this phrase came from. And a handful of you guys in this room, when I got here this morning, I said, Frank, I wanted to chat with you because you and I have someone in common, Scott Shannon. So that phrase, if you ain't cranking it, you must be yanking it. It may have come off a tower here in Alabama and then down in Florida, but I do know that it came off a big building in New York City when I was working at Z100. So, Scott, I've kind of swiped one there from you. Okay, I want to give you a little overview of our agenda, because again, we can get down and dirty and talk about some specifics, and we will, but audio processing, as all of us know, is a very subjective thing. You know, one of the things I love up north, and I know you guys have it the best down here in the South, is barbecue. In fact, Memorial Day weekend in the Cleveland area, we have well, they call it the National Rib Cook-Off, but doesn't everyone have a National Rib Cook-Off? But I like to use a barbecue analogy because I like barbecue that's got a bit of a sweetness, but that hidden, you know, hot thing that knocks you on your keister, okay? Some people may want it sweet, some may want it, you know, more dry. I say that because audio processing is the exact same thing. You know, I cannot tell you, I've been doing this professionally as a business since June of 1988. I cannot tell you how many people have called me or emailed me or texted me and said, Frank, you got to share with me the secret preset. You got to give me the secret settings. There are no secret settings. There are no secret presets. Why? Because something that we could dial up in here today with this test setup, we could go put on the radio and it can kick butt. Then we could drive down to Tampa and it could fall on its face. It could be too much or too little. So we'll get into a little bit of that, but we'll do a processing overview, a little bit of history. We'll look at a processing system. I'll go into an insight on a new FM limiting method that's evolved into our current line of processing. The processing part for coded audio, the reason I'm calling it for coded audio, because when we get into the HD radio side, you know, it's really, you know, the HD radio side is coded audio, and the only difference between it and streaming audio is that one's going over electromagnetic, you know, air, and the other one's going over a pair of wires or through some Wi-Fi. So coded audio is coded audio, no matter which way you want to look at it. And then, you know, one of the things that my late brother from another mother, Steve Church, and I have always been kind of into is cool stuff. One of the things, if I may say so, we always tried to pride ourselves on was not to do any wannabe products, Me Too products, but to try to be leading, be out there as innovators and be leading the marketplace, and hopefully we're doing some cool things. Now, for some of you, if this is old school, I apologize. But before I trip over it, I'm going to set this guy over here. Why do we need audio processing? Well, we know that here in the United States and really throughout the rest of the world, although maybe not as well paid attention to in other parts of the world, we have to control modulation. And we need something that's going to say the transmitter is only going to modulate so far and that's it. And that's the number one job of the audio processor. 100% modulation is 100% modulation. The other part is what we call the psychoacoustic response. Plainly said, that's the PD going, we're not loud enough, we don't have enough bass, we're not big enough, we're not round enough, we're not fat enough, doesn't have enough punch, things of that nature. So, we're kind of doing a couple of things here. We have a technical job to take care of. And by the way, all products on the market today, they take care of the technical part. It's the psychoacoustic part. That's the part that, we'll be focusing in on. It's kind of that ethereal thing. That's why I use the recipe, because your recipe for barbecue ribs may be different than yours, but they're both great. Also, the listening environment and the consumer convenience. I'm just sharing a story with Larry. Within the last month, I made a little pilgrimage to Boston. Very well-known classical radio station. They're so happy with what we've been able to help them with, they're going to go out and tell the story for us, WCRB. Very well-known classical highbrow radio station. They'd been processing with different products for a long time. They have a new manager in there, and to him, they had to back the processing down so far because the oboes and the violins were sounding shrill and the pianos had all the transient impact removed, that when they backed the processing down, all those problems went away, but they couldn't be heard on the dial. He'd be driving up, or driving across Interstate 90 there in Boston, couldn't hear the radio station. WZLX, the rock and roll radio station, was blowing him out. Granted, he was not competing with WZLX, but he wanted to be heard on the dial. So what we ended up doing was we were able to help them out to where when we were done, and this gentleman, by the way, had worked with Luciano Pavarotti and the New York New York Opera and things of that nature. This guy was a nitpicker. When we were done, he went over to his radio, and to his ear, WCRB was as loud, if not louder, than the rock station in Boston. So there is a whole, psychoacoustic, psychological thing that audio processing does provide. And I guess that kind of touches in on the item 3, competition, psychology, and marketing. Some of you were asking me about, Scott Shannon. I was privileged in 1983 to put Z100 on the air in New York City. Scott came in there. You can look it up. We went from worst to first in one rating book in New York. The programming was phenomenal, but we reinforced it by having an over-the-air sound that was the loudest on the dial and the best sounding on the dial. I think I was sharing with Frank that we used to describe Z100 in the same way that Roger Daltrey of The Who described the music of The Who. It's like getting punched in the nose and, when someone's telling you, I love you. It reinforced that competitive level. I could walk down a shopping mall in New Jersey, and as I was back in the days when, local stores would play the local radio stations, I'd walk down. It was my first practice attempt at marriage at the time, and I was walking down. I would tell my wife, I'd say, that's Z100, Z100, PLJ. I knew the sound of the station so well, and I knew that there was something magical that people didn't know, why Z100 had this additional sound. Some people might say, well, you were overmodulating, and I'd say, well, we were not overmodulating any more than the other guy up the dial, and we'll get into that topic a little bit later. The loudness debate. This gentleman here was, mentioning that about their stresses with loudness on source material. Loudness has always been an issue on the air. It always will be an issue on the air. There's, you know, the reality is, I don't know if, what was there was a dog food when I was a kid called Kennel Ration. Did they have that down here? And there was that old ad, my dog's better than your dog 'cause he eats Kennel Ration. It's the loudness thing. My radio station's better because it's louder. When I say the loudness debate, you can get to a point where, you know, too much of any good thing is not good for you. You can get loud today. You can get loud and nasty. You can get loud today and sound loud and good. It's how we get there. And it's all the different items that get into the equation that cause this last item to be good or to be bad. And we're gonna talk about the items that affect all of that. This is probably in giving a lot of thought about the definition. I've had people ask me this. It's the art and science of instantaneously manipulating audio dynamics and frequency response with the intention of creating a personalized signature presentation. Some people call it black magic. I mean, obviously there's some engineering in there. Believe me, there's some very heavy engineering in there. By example, on this little computer, I do a lot of algorithm development today using a program called MATLAB. And recently, in trying to, the key word here is trying, to influence 16-year-old stepdaughter about why there's a need to do your homework. I'm guessing many of you have probably had this situation with kids at home. And she was saying, I can't get it, I keep doing it. And I opened up the folder that showed about 150 files of a Clipper design. She goes, oh, you have that many different versions? I says, no, her name's Milena. I said, no, Milena. One of those is the right one. The other 149 are all the mistakes I made. There's a lot of engineering that goes into this stuff. But it's how we, you know, we mix it in with the black magic part, the art, you know, where it comes to having the ears and knowing what to do and which adjustments to make and how to apply it. You know, that's when, you know, you really get in the zone and you're able to get the sound that we're looking for. I guess I kind of, before I even put it up here, you know, it's where black magic and engineering meet. History of audio broadcast processing for broadcast. Actually, probably the first ones to do it were the BBC and I believe the CBC. Many years ago. And again, it was really used as a tool to ensure that the transmitter, be it at the time, you know, in Europe or in England, which they would have called medium wave, or FM, was not over deviating or over too much amplitude modulation. And then probably the first one here in the States, you know, sadly he passed within the last 10 years, Emil Torek of CBS Labs up in Connecticut. I mean, you know, many of us have at some point dealt with what we call the Max brothers, you know, the Volumax and Automax. You know, that was a good step in the right direction. And then, you know, another guy who I like to think, I think that I've probably followed in his shoes in a lot of ways, is Mike Doreau. You know, Mike was working out in Los Angeles as a broadcast engineer and had a wild idea that said, you know, the challenge is all the stuff is wide band and get something with a lot of bass and pulls everything down. What if I create a, you know, frequency dividing network and split it up into 3 different frequency ranges and, you know, the early DAP that Mike developed, discrete audio processing, set the world on fire. I mean, Mike would build them on his kitchen table along with his wife Kay. They'd load them up into the trunk of their car and drive to some market, knock on the door, put them on, and, you know, made such a big difference that, you know, they'd sell them, go back to LA and build more. And then mid-70s, Bob Orban. You know, I know a lot of people say, Frank, you guys kind of go at it like the Browns and the Steelers used to go at it, you know. We're hoping, keyword hoping, that maybe the Browns will get back on the field with some real players. But I have a lot of respect for Bob Orban. Yes, our companies compete very strongly. I'd like to think that we've made each other better, but Bob was the first one to tackle the whole issue of low-pass filters and overshoots on FM, and he obviously did a number of great things on AM as well, you know. And then the last part there, some trainiac kid from Cleveland that, you know, can just go on meandering, and for me, it grew out of being in a radio station. I was at WMMS in Cleveland back when it was the big bad buzzard, and the whole idea was, you know, to have the buzzard be the loudest thing on the dial, sound the best it could. And I was lucky to be taken under the wing of a guy who was my mentor, who unfortunately is not with us anymore, and he dabbled in this part of the business. His name was Jim Somich, and Jim taught me the ropes. Great mentor, great man, great engineer as well. And we prided ourselves. I mean, the first thing I did in the morning was I put the radio on. There's MMS, and at the time their competition was an album rock station called M105, now Magic, an oldie station in Cleveland. And, you know, the moment, if ever I heard, you know, M105 doing something that I thought was better than MMS, first thing I did was got in my car and I went to the transmitter. It's like, we got to beat them, you know. And I'm, quite honestly, I'm that way to this day. You know, I have all our competitors' products in my rack. You know, I download their latest versions of software, you know, and race them. And actually now, because we've got other guys developing stuff within my own team, my guys are racing among themselves. It's amazing to watch Cornelius Gould, you know, the Clarence Clemens, if you will, of our little, you know, Omnia Street band, and Leif Clayson go at it. It's the greatest, you know. But in any case, I'd like to think, you know, that we've been honored to be in the company of these other folks, and it's where we are here today. And you know, we'll talk about processing for broadcast today, and I'll even try to peek into the crystal ball a little bit with you guys as we wrap up later on. Good processing requires more than just a box and a few tweaks. It's a combination of numerous functions working together. Source material, your playout system, the studio, the STL, the processor, transmitter antenna combination. For FM, you know, we all know in AM it means everything. You know, I mean, I always took a lot of pride in getting an AM radio station sound as best it could, because it was always, you know, what's the ground system, what's the antenna like, what's the matching network, how good's the transmitter, and then the audio processor. You know, I was blessed to work at this AM station in San Francisco, KNEW. Its only challenge was it was on 910, which at the time was, you know, 2 times 450. You know, you'd get that little IF whistle, but the towers were on a counterpoise in the bay. Talk about a ground system. I mean, that sucker got it, and the tuning on those things was as broad as could be. And at the time when Bob Orban brought out the 9100, he brought a beta version over to the radio station one night, and we put that thing on. I kid you not, I thought it sounded like FM. It just sounded so beautiful. But that's a perfect example of the whole system working together. In FM, believe it or not, it matters. When I was in New York, Z100 was station 11 going into the old Alford antenna system, which was only designed for 10 carriers. We were 11, and it was an add 1, which meant we went through every combiner all the way up. And we were lucky because when we put it on, they had to do some antenna work. And Robert Silliman was still alive at the time doing the consulting, and he was up there one night, and he needed a carrier to tune the whole system to. And he said, I need something around the middle of the dial. I went, oh, Mr. Silliman, you could use mine, which he did. So we got the whole, excuse my language, the whole damn thing maxed out to where the group delay was the best on 100.3. Why do I say that? Because group delay through an FM system will affect how everything sounds. So stations with combiners, especially now with HD radio, if you're doing high-level combining, all of that matters. Same for the antenna. And oh yeah, the last part is someone who knows what to do. So let's take a look at some of these items. Source material playout system. You know, the reason I put this up here, and this is not, and by the way, I see some of you guys taking notes. I have this available as a PDF. I did email it to Larry, but if they don't have it, get me a business card. I'll be happy to email it to you. So if you want to take notes, that's fine, but just want to let you know that we'll be covering a lot of material today, and if, you know, I do have a way to make it available for you. Source material playout system.
It's actually already up on the FTP site, the AVA's FTP site. His presentation is out.
This young man over here is a step ahead of me, and that's the way I like it. Source material playout system. We were talking about source material that's hyper compressed. You know, if there's a way to get better versions of that material, or there are some production utilities that can undo some of this stuff, that's a benefit. You know, it used to be, you know, I'm dating myself, obviously. In the good old days, you know, and I always thought it was extremely well written, and I think you can even download it off the Orban website. Bob wrote a great piece on all the quality considerations in your broadcast plant, and I remember how he talked about, you know, back in the day when we used to play records. This is a great crowd because we know what records are. You know, the 16-year-old in my house, we got her a record player because she started buying records at, like, you know, thrift stores, and so I set it up for her on her birthday, and she's like, what are all these groups of, you know, she didn't realize that all the bands of, you know, the grooves, she didn't know what that was. You know, I mean, to me that's wild, but I'm sorry, I digressed. But I remember Bob used to say, change the styluses every 2 weeks. You know, I mean, so, you know, in today's day and age, obviously, we may think, oh yeah, it's all plug and play like Larry was mentioning, but you do need to give thought to it. If you're running digital, you know, how many sample rate converters are in the system? You know, if you're running a whole, you know, linear digital plant, you know, hopefully if you can keep sampling rate all the way through at one sample rate. Another thing is, know where your headroom limits are. You know, some stuff might be 24-bit, 32-bit. You want to know that 0 dBFS in your system is truly 0 dBFS. I giggle on occasion where somebody will say, Frank, you really need to see our system because we're all digital, and we have a digital compeller before the STL, and then we have your box out the transmitter. And I'll say, okay guys, let's think about this for a second. If we know that 0 dBFS in the console equals all the way through the system 0 dBFS at the input to that guy, isn't it all the same? I mean, technically it is. Now, in the days of analog, there were some guys that would go through and they would calibrate everything to find whatever piece of equipment had the least amount of headroom, and then they'd calibrate everything else to equal that, so that, you know, whenever a device would go into business, if you will, meaning run out of headroom, you knew you were out of headroom. So it's items like that that truly do make a difference. On the playout system, and this is important, I tell people all the time, you know, with the advent of digital storage being so cheap today, hopefully all your content is linear. If it's not for whatever reason, please make sure that whatever bit rate is used is as high as possible. You know, running MP3s on the air, you know, 128 or even 256, 192, it doesn't get it, because the minute you know, the stuff that's on the edge, no matter how much distortion control we can put into the, you know, I keep pointing over it because it's sitting right there. At some point, at some point something's going to give up. So the whole thing with regard to source material playout system matters. Clean audio is a must. I think I've gone through most of these things here. And your source consistency really does matter. So as we take a look at the reason I have this thing up here, it says, "You're killing me, man," was part of that Scott Shannon School of Programming. There's a guy that worked under him who also did a lot of great radio on the up the East Coast, a gentleman by the name of Steve Kingston. He was our operations man. Steve, I love Steve like a little brother. He's a few years older than me, but I still call him a little brother. He's got that Napoleonic complex. He's about this high. Yeah, you're killing me, man. You're killing me. So even to this day, I'll send him I'll get on Facebook. Steve, you're killing me. So I had to get him in here. But again, clean audio is a must. I know it's a broken record. I think we've hit some of all this stuff here, and being able to normalize your gain through the system. But again, if we've got the system set for maximum headroom, such that whatever the maximum point is on the console, if that's going to be equal to everything else through the system, you're okay. Obviously, if they run the level too high and they're hitting zero, obviously, then they need to make an adjustment. But what we're trying to do here is to make sure that we've got the system the best possible, calibrated the best possible, so that when you turn it over to the people that are going to kick butt on the radio, they've got a weapon that'll be of best for them. The STL, it's always, to me, I've always viewed it as the Achilles heel. When we're doing analog, we're always, getting, if we had noise get in the system due to weak signal, that was always a challenge. But since we have a lot of digital in the world today, obviously the first digital STLs were all basically coded. Again, the more we can eliminate coded audio in the system, the better. Pay attention to sampling rate. Now we're getting to a point now where we have things where, with the advent of things like audio over IP, and slowly coming into the world is the ability to have high bit rates over a long range. I think some of the challenges I'm mentioning here are basically going to go away. By example, talk about high bit rates over IP. At the recent Winter Olympics, Swedish radio, they had a digital IP link from Russia to Stockholm that was basically a WAN, and they ran Livewire all the way from the Olympic Games back to the radio house in Stockholm. So technically, the sound that was leaving the Olympics is what they were able to deliver to their listeners. I say that because there's technology like that that's beginning to become deployed in the telecommunications world, and at some point I do see that becoming more vanilla-like with regard to broadcasting. Composite systems, I've always been a fan of this. Wherever I could send composite from the studio to the transmitter, that's great. My running partner today, Jeff at Nautel, it was a little over a year ago. We had the pleasure to work with their group to basically create the whole MPX over AES scheme. Now, basically what we did was we put our heads together. We realized that utilizing a sampling rate at 192 kilohertz sampling, we could take the composite signal, put it into the protocol transport of what AES is all about, and get it from point A to point B. I like to laugh because it's amazing to me that in order for this to work, we had to put this on the air somewhere between our company and Nautel, which meant that we would have had to, God bless you, we would have had to have been the first in the world to do this. Yet I laughed when I saw ads by other companies that were, doing that Me Too tech, saying that they were the world's first. That's kind of odd, or kind of interesting. But such is life. We move on. So let's have a look at some of these things. Obviously, with the audio processor, some of this, it's easier said than done. Getting to know the audio processor, get to know the box. I know in today's broadcast environment, it's much different than when I was in it. When I was in it, a new audio processor came out. It was like, to use an analogy from my hobby, it's like a new model coming out. I could take the time to get to know it or build it and get all the great enjoyment out of it. I know today's world, predominantly, a lot of you guys don't have the time. You know, I was able to devote a few weeks at a time to get to know it, get it on, and make the adjustments. Today, we, myself, and within our company, we know and understand that, you know, time is very precious. But still, where you can get to know the box, it does pay off in the long run. And I'll be going into this topic here in a little bit. If digital, meaning you want to go left-right digital output from the signal processor into the exciter, sampling rate should be 48 kilohertz or higher. You know, I can go into a whole half-day dissertation on that topic, and you know, and if you really want to dig back, you know, on the old BNet, there's probably still some blood and carcasses left from the late 90s between Mr. Orban and I on this specific topic. You know, if you want to listen off the air, because I know not everyone is doing HD, the bone conduction monitoring from, you know, your own hearing yourself, the latency should be 10 milliseconds or less. You start getting over 10 milliseconds, people can begin to have that disoriented feeling because of the, you know, of hearing themselves come back a little bit longer than normal. And that's why with the current generation of digital signal processors, you know, the 11 does have a latency that's longer than 10 milliseconds, but for that note, we offer a low latency monitoring output. Current generation do offer a wide range of capabilities. Again, another reason to get to know the thing. Network access for adjustment. Later on today, we'll actually get into that one by way of the network here. And it's highly recommended that you have someone who knows how to fly the plane, or you have access to someone who knows how to fly the plane. And hopefully it's not someone like this. Actually, this guy, this person here, his name's Scott